Hi everybody, I'm Dr Sharmila Goedhart. I am Head of Science Operations for SKA-Mid as well as for MeerKAT. I work in Cape Town for both radio telescopes. So my day-to-day would probably look very boring to an outside observer because I'm in meetings a lot, I'm on the computer a lot. So basically science operations, this is a senior management position. I am also still a scientist by training, and I really love seeing what's coming out of the instruments that we're building, but my primary task at the moment is to build highly trained people, teams of people that can run the telescopes and deliver quality science. Okay, being where science and engineering meet is interesting. When I initially joined the SKA Africa project back in 2008, was quite a learning curve to learn how engineers think about things. They've got very different terminology, they've got very different focus, and they've got very rigid methods. Now, scientists tend to be a little bit more fluid and want to try things out, and sometimes not very systematic, sometimes they are. But the engineers are very precise and ordered in their way of doing things. They don't like uncertainty, whereas scientists thrive on uncertainty because that's where the interesting stuff is. So how do you balance not knowing exactly what you're going to need in 10 years' time versus what we actually are building right now? So there's that whole communication, back and forth iterations of ideas that goes between scientists and engineers constantly as we adapt to each other. Primary challenges in science operations and commissioning is actually just trying to meet deadlines. Those are, and you actually have to think on your feet sometimes, because you might have a plan that you're going to be observing this galaxy next month with a very high spectral resolution science mode, and then realize that things aren't working exactly as well as you wanted to do, but the telescope is capable of doing some other type of observation, some other science. So we have to be very flexible and change priorities, change tack quite a lot. Okay, so this again boils down to the role of engineers versus scientists and the sort of things that we do. So commissioning, well, there's two types of commissioning. So there is an engineering commissioning, which is putting everything together and making sure it all works as planned. So that you can turn on the telescope, you can turn on the correlator, you can point the telescope to a particular spot at the sky and capture a signal. Now and often there's a lot of internal tests that they do with set test equipment in the laboratory, that sort of thing. But we as astronomers, we're looking at the sky. The sky is an unknown quantity to a large extent. So how do you basically calibrate that telescope? How do you work relative to the sky instead of relative to man-made calibration instruments? And we've got these engineering instruments, engineering requirements. Is that properly translated from the astronomer's needs? So what we will do is we'll set up a series of tests to look at things where we know their characteristics very well. So these are so-called calibrators. So we'll observe them and we'll compare results with other telescopes and see if it meets that. Sometimes we find slightly weird things, so then we will write bug reports and send it back to the engineers to to correct. And then ultimately what we want to do is take some target that other telescopes have imaged very well. And then we will image it. We will try to make sure we reproduce that result, but then we want to see, can we surpass that result? And that is when you start getting the new science. Take something that's known and then see it to greater detail, to greater sensitivity. So for instance, the Deep 2 image, which we should maybe talk about sometime, is the most sensitive observation made at that frequency. It is incredibly deep. So initially it was kind of like matching other telescopes, but then we just carried on observing. We were busy testing the telescope, and ultimately we just started seeing all these very faint sources just coming more and more clearly detected as we carried on observing. And so at that point we know, okay, we are ready to do this type of science. Well, first of all, I mean, if you're a schoolgoer, you need to be focusing on mathematics and science, in particular physics. But the mathematics is also important. These days, most of astronomy is software driven, so having a good ability to program is also extremely valuable, even if it's just in something like Python or scientific computing. So those are the things you should concentrate at while at school, because that will give you an edge when you get to university. When you get to university, there's a couple of options. I mean, a number of universities offer an undergraduate degree in astronomy. But if they don't, or if you've got some favorite university that you want to study at, just studying maths and physics and computer science, those are very strong subjects that will serve you well. Even if you decide to do something else at the end of your degree, these are learning how to solve problems, learning how to think analytically will always be a handy tool in your back pocket. Well, I think, I'm seeing the face of science and the face of astronomy changing now. There's all this stereotype of an elderly white male, beard, white coat kind of thing, but science is being done by our people who look like me, people who look like you. Way back when we were initially bidding to host the SKA, there was a lot of discussion of a term called Afro-pessimism. I don't know if it's still being bandied around. I haven't heard it for a long time. But this idea that Africa is lesser in some way, or that we can't do it. And what I'm excited about is that we are proving that we can do it. We are as good as anybody else anywhere in the world. And, just really starting to see us shine and step up onto the world stage in science and technology. To me, that's really exciting and inspiring. Right, so I'd say the one thing is, if you have a passion for astronomy, it's hard. You have to learn a lot, you have to work a lot. Your friends might be going out to party and you're trying to finish your assignment for Friday. Just get your priorities in your mind right. Let's say like, okay, I want to do this, and I will need to work to do it. But then just go for it. That's the best advice I can give to you. Don't look down on yourself. Don't think that you can't do it. There's a phenomenon known as imposter syndrome, where you feel like you don't belong, you're not good enough. I still struggle with that sometimes. But and it takes time. Like, just know that within yourself you are capable. you can be that great person, the next great scientist making big discoveries, or maybe even going for the Nobel Prize. It's not out of your reach.